That is the most fired up I have ever seen him, ever. And I've had him on the golf course kicking him hard, and that's the first reaction I've ever seen. Hey, thanks for being here, and we appreciate your interest. Give it up for ESAB for putting this together. Come on, give it up for ESAB. Educational sessions. You know, I want to do something here where I'm trying to encourage people. We get asked a lot about code procedure welds and how to get past some of the stuff. What'd I do? I can hear myself now. Do you want me to start over completely? No, you don't want me to do that. So one of the things was, you know, how do we get this TIG root, MIG filling cap? I'll tell you from my personal experience over the years, I did this a lot in boilers. My past experience, I could go through and qualify myself and tell you my education, my certifications, and all the stuff that I've done over years. It doesn't matter. Okay, it doesn't matter that I've bowled 9 300 games left-handed and I have 3 hole-in-ones right-handed at golf. Doesn't matter. You don't know what I know. It doesn't matter. You need to know how much I care. I care about the welding education and the success of how to understand and do some of these procedure welds, right? So, you know, one of the requests we get, and we do this a lot, and I teach this a lot, is a TIG root, carbon steel, stainless steel, MIG fill-in cap. Okay, it's you know, these processes and procedures. I got a quick question for you. Is there a pre-approved short circuit code? Is there anything pre-approved? That's my inspector, Joe, a gentleman here.
For pipe or plate?
Doesn't matter.
Yeah, there is.
There is one pre-approved.
Yeah.
For short circuit. My impression is he always had to test the procedure.
For D13, so up to 316.
Okay.
Not D11, so nothing over, so 8 inch and over.
Okay.
D13, yeah.
Okay.
So 316 is none.
In any event, you know, you'd think because of short circuiting, it lends itself to lack of fusion. We do uphill processes, okay? And we're doing this in high pressure. We're doing this in boiler codes and stuff, so ASM EB313. How many of you TIG weld? How many of you TIG weld pipe? How are you struggling with it? Because I did when I taught myself. You know, I didn't have anybody teaching me. I kind of taught myself, and I was doing it off of a 1958 crank model SA200, smoothest running machine I've ever run in my life, and I was doing it in my garage, and I struggled. And the funny story about it is, you know, I'm left-handed, and man, I got that down. I was feeding it, and then I had to switch and do the right-hand thing. Woo, that was brutal. I had a pile of tungsten. My tungsten looked like a bunch of Q-tips, you know. I dripping the filler wire on there. Now, it was frustrating. It's like getting up on one ski, water skiing. You know, you eat half the lake before you finally figure out how to get up and go along. And so I switched back so that I could make sure I had both hands going. Guess what happened? I'm naturally left-handed. I couldn't weld worth a hoot left-handed all of a sudden. I could weld right-handed real good. So it's that manipulation and that hand-eye coordination. And once you get that, you know, and there's multiple methods. No two people are going to weld the same. If you watch some of our videos, Hamar Aguilo with South Coast Welding Academy, weld tube, we did a contrasting style. We've done it on stick, we've done it on MIG, you know, he'll run stuff a little different than I do. We're both getting to the same place. So, you know, what are we trying to do? We're trying to put a root pass in that has fusion, that has reinforcement. You know, when we get done, you can't tell if Nate did it, or I did it, or Hamar, or the camera guy. Well, you probably don't want the camera guy doing it. But anyway, you know, we're getting to the same point. And that's what I'm trying to encourage you to understand this whole process, or any process for that matter. So, moving right along. Ouch. So, the demo today was 6-inch schedule 40. Multiple methods of tacking up, fitting up. A lot of people put 4 tacks in. Some people put 2 tacks in. You can go with a fairly long tack top and bottom so that when you get to them and you just bump in or tie in, you can feather the tack out, whatever. I, over the years, have found that I just put 3 tacks in. I'll put a fit tack at 12 o'clock. I'll put another tack at 2 o'clock and one at 10 o'clock. I want the whole bottom to be open. Okay? I can't do this weld for you out here in space. I'd like to, but I can't. But I can, with the whole bottom open, no restrictions to me. I can rest the wire on the tack and I can see everything down below. Okay? And it's always worked for me, and again, it's like one of those my personal opinion thing. If it works for me, I found it to be easy, so I don't mess with it. Okay? I also don't have to do a bunch of grinding. And most generally, when I come up to one of these tacks, I can manipulate the torch and warm it all up, add a piece of filler wire back up and just cruise right through it, and it blends and becomes part of the regular route. Most of the time I can hit it fairly good. I will tell you straight up, I have not practiced this weld in quite some time, and I'm nervous as a cat on a hot tin roof that I'm gonna mess it up. But you know what, if I mess it up, I'm human and I'll admit to it. How about that? Now seriously, I've been really busy. I've had some equipment go down in my shop. I teach 30 people per day, every day, and I just, with time constraints, I just haven't been able to practice up. But I'm gonna go ahead and do it. I'm scared, but I'm gonna do it. I'm gonna have to put this on the table back behind. I'll tell you what I'm doing. I'll show you what I'm doing with the torch. But for art flash, I've got to be back here. You liking that? If I get bored, I'll just go over by the speaker there and make some noise. I've got gloves. Did you want to put a microphone on me too? Everybody else has.
No, I'm good.
You good?
Just the camera.
What do you got there, a little GoPro?
A couple little GoPros.
Sweet. Let's talk about the Sentinel hood real quick. Does anybody run a Sentinel hood? What kind of lid you got? You got a Sentinel? Anybody? Been welding for 45 years. I think I've only owned 7 welding hoods, one of which I've given away. One I kicked off the top of a tower because it deserved it. The most uncomfortable hood on the planet. I kicked that thing off from like 60 feet and made it shatter in the parking lot, and I felt better about it when I did. The rest of them I actually still have. I can make an old pipeliner run for 20, 25 years. I didn't use auto dark for a long time. I used number 9 glass, number 9 passive glass. That's what I'm used to. But this came along, okay? And I've tried a lot of auto dark lenses, auto dark hoods. They're not fast enough. It's like when I strike an arc, I've got to reacquire vision or something. I black out for a second. I've got this line in front of me and I'm going, I don't have time to wait. You know, I'd rather just drop my hood and go back to the glass if that's the way it's going to be. This is not like that at all. I quickly acquire vision. I set mine up with a number 9. Oh, nice.
Let's swap out.
Why?
Because that one's cooler.
No, I've already
one?
set this one. I've already set this one up. Auction that off later on there. You make some money. You can sign it. You'll make some money. I set this up with a number 9, the sensitivity at about a number 8, and I don't do a delay, okay? And I like this. I plasma cut a lot of pipe every day. I'm re-beveling off of a positioner. I like this hood. This is a quality product. The ESAB is not paying me to say that, okay? I'm just being real honest with you. Real honest with you. If it doesn't work, I'm not gonna use it. And I'm telling you, this thing is super comfortable. You know what? You know what was hard to get used to? I'm always used to raising my hood and it's up here. This thing is like a low rider, and when I first started wearing it, I thought something was wrong. And it was just getting used to it is all. But I like it. I like it a lot. Okay. Couple of things. You've seen guys, you've seen people, I don't want to say guys and girls. They're coming off the bottom of a piece of pipe and they will hold this completely upside down and walk along. There's so many methods of hanging onto a piece of pipe. Mr. Aguilo will put 3 fingers on the pipe. He's holding onto a torch like this. Myself, I grab it right here at the neck and I put my thumb against the pipe and manipulate my filler wire till I come off of the bottom of the pipe till I get about 7:30, 8 o'clock. And then I rest the cup in the pipe and just keep right on going, okay? I've already done a little bit of a test run here to make sure things were going. So I've got a small amount of weld down here on bottom, and I'm gonna start on that and just walk the cup up. I use 1/8 inch. This is 1/8 inch 70S2, I believe. I can tell you straight up that I don't like how this wire is flowing. At all. How's that coming through?
Not at all.
Not at all?
It got knocked out.
Got knocked out?
There you go. Go back. Once again.
Apparently, High Freak Start knocks this camera out for a second. Does it come back?
Thanks.
The classic dip. I like to keep the wire right on the leading edge. I don't like pushing on the wire, but 70S2 does not flow in very well at all. To me, it's real sluggish. I'm nearing the top and I'm nearing attack. Are we able to see this? What's going on here? I can kind of talk about it. Seems like when I drop my hood, it gets real loud, but I'm getting ready to come up here to the top and bump into one of my tacks. So when I get there, I want to heat that tack up. I could grind it out. I could completely take it out. Die grinder, cutting wheel, 1/8 inch, something real thin. I can completely cut it out like it wasn't even there. All it was a fit tack so that it won't close up. So as I come up to this, I want to heat it up, add filler wire, bump into it, blend it, and keep going. So I turned my torch over. While I was coming up this pipe, I lightly hang on to it, rest it in the groove, and I'm walking up the pipe. When I get to the top, I'll just turn it over. Again, relax, light pressure. Knock your pipe over. Okay, so there's half the route. How many of you, when you're doing any open groove work and you come up to, you want to terminate your weld, how many of you have seen, like, you just suddenly stop your weld, quickly terminate your weld? What do you see in the middle of the crater? You see a little hole, okay? It's called piping porosity. What you see is a little bitty hole might geometrically be laying in there. It might be 1/4 of an inch long. That's why we always kind of terminate our weld. We'll come up on the sidewall of a groove or the piece of pipe, and that mass keeps that weld pool from shrinking so fast that it knocks that hole in there. Okay, you can remelt them if you're doing some of the code work and stuff, feather them out, but it's best just not to leave them in there at all. So I always kind of crawl up on the side of the piece of pipe when you terminate the weld. Now, what we've got done so far. I'll leave half that open so we can inspect that later, or the camera guy or man cub can come up and do the other half. Now, I want to do something where I switch cups. I'll put a little bit bigger cup on here and put a light fill pass in. I may not use all of that, but I want it. I want 170 amps. Okay, I may not use it all. What's the worst thing I could do right now? Remelt my root pass. Okay, don't want to remelt my root pass. In the Schedule 40 pipe, do I have room for a MIG fill pass and a MIG cap? In my experience, no. It can be done. Turn your wire feed speed way down, float it in there wet. You don't want a profile that's high and crowned up, okay? Also, if I put a MIG fill in here, I'm probably I'm probably too full to put a cap in. So I can use the TIG process all over again to do a light fill, leave that profile where I want, and then when I put the big cap in there, it should be at a level that it just goes in nicely, okay? So the whole point of that is, you know, what do you want when you get done? You see, you know that your weld needs no undercut on the side, and you can't be more than 1/8 of an inch above the pipe, okay? So we know that, and so we can kind of manipulate our technique and work around that, correct? Okay. Oh, I was going to do a fill pass, my bad. It feels like I'm using all 170 amps now, which is plenty hot. I'm leaving the wire on the leading edge of the pool, and I'm trying to spend more time out in the sidewall of the pipe, out in the bevel. Is that coming through pretty clear? Okay. So now I'm kind of built my profile. The weld's laying in there pretty flat, which I like. And again, I'm just trying to get enough fill in here so I don't, if I just went straight to a cap right now with the MIG, I'd be carrying way too much hot metal. Guess what happens? Porosity. You make a nice MIG weld in a groove and it's dark gray and it looks kind of strange. That's too hot. Okay, regardless of where the machine was. If you're carrying that much metal, it just becomes weird looking, and I've seen a lot of porosity with that method. That's why we like to do a fill pass. Again, real light pressure. I'm generally hanging on this with 3 fingers all the time. I'm really not doing anything with the filler wire other than when I've got it resting on the leading edge of the pool, I put a little bit of pressure on it like that. Sometimes, depending on what's going on in the groove weld, I'll actually roll this back and forth and I'll chase the arc to get a different type of fill, and it works out pretty well. I use 5/32 filler wire a lot, big wire. I'll put root passes in 8-inch pipe. I'll put fill passes in. Actually, there's times I've used 3 1/8-inch filler wires side by side to do a fill or a cap. And that's a lot of filler wire, but when you're running 180, 200 amps and you need to get that profile and you got a large groove, after that, I go back to running stringer beads. It's just too wide. You're over here walking this thing back and forth, so. All right, let's test some MIG, see what happens. By the way, Good? Here's where we're at so far. Okay? So I have left these edges alone and I'm fairly flat. I like that depth because to me, 035 short arc, that will fit in there nicely. When I put this last pass in here, I never weave the wire outside of the groove. I don't like that at all. It creates undercut. To me, I can't make a consistent width all the way up. So I use the bevel as a guide. If I always put my wire right on the inside edge of this bevel, then all I have to do is wait for the weld pool to come around and wash that out. And I use a technique. Again, there's many different styles, you know, and by the way, don't tell me I have to run my machine at a certain voltage and a certain wire feed speed because we're going to get in an argument and you're going to lose, okay? Every machine, I can have multiple rebels over here and set them at 17.8 or 18.2. They're all going to have just a little bit different output, okay? Things change. My coupons might be superheated. I'm sorry, my coupons might be hot. Therefore, I can turn my values down and make the same weld, right? So as far as the heat input and what your values are and everything, I believe I have this set at 17.8 or 18. Inductance at 35. I want a nice smooth short arc, wire feed speed, $180. Here's what's gonna happen. When I pull the trigger within 2 seconds, I'm gonna know whether I need to stop and make a value change, okay? And I've worked with a lot of people that, have you ever been in a fab shop and somebody's putting scratch marks like on their old machine? I laugh at that because I think that's funny. That means on one certain day at a certain temperature and all the good power input was there, the machine was running nice and crispy. So they went over and put a Sharpie mark where the volts and the wire feed speed. They come in, they turn the machine on and they go set them like that and they leave them there all day long. And they put down a bunch of crappy looking welds because the settings are wrong, you know? Adjust your machine, understand how to adjust your machine. You got to understand that relationship between voltage, wire feed speed, okay? Good with this so far? Who wants to come up and throw the cap on there? I'm working off of a table back here, and I don't have a whole lot of room. Oh, for pity's sake! That wouldn't happen to anybody else but me. Hey, I got a quick question for you. How many of you be welding long and your lens fogs up? Anybody? What do you do about it? Stop, cry a little bit. It's irritating, isn't it? Learn to breathe. Learn to breathe. Breathe through your nose, exhale out your mouth and blow it down. Your lens won't fog up. I know that's annoying and it happens all the time, even when it's warm outside. I've had people in my shop that try to weld without safety glasses on because they think they got a hood on. It never works out for them. Got to wear your safety glasses. Okay, my torch and my manipulation. I'm going to hang on to this thing. Again, I hang on to these light. There's times when I'm making MIG welds that it'll cut out, it'll stop. It's me because I have a real light trigger finger. I want to be able to move. Okay, and I'm not one to cram my face in a weld or get my hands up in a weld. Always remember the center of the pipe. You have to reference the center of the pipe all the time. So if I start out and I'm at the center of the pipe, as I'm doing my technique and coming up to the top, I'm up here like this. When I get to the top of the piece of pipe, look where I'm at. Okay, here's what happens with a lot of people. They'll start out on like the side or the bottom, they'll come up a little bit and they never change this angle. They start out here and they're correct. They get up here, look where they're at. And you got buckshot and BBs and fire blowing out the leading edge of your weld pool and you're creating lack of fusion. Okay, always reference this. I like my wire on the leading edge of my pool all the time. It's quiet, it's crispy, I can see what I'm doing with the fill. And the other thing about the fill is, how many MIG welds have you seen that look like big figure 8 cat paws going up? That's somebody moving in a big diagonal. What did I say? Is that funny? What? What did I do? I like to kind of come up in a real flat, lazy triangle. So when I leave one side of the bevel, I go up into the middle of the groove just a little bit, come down very little, and then come back toward me straight and flat. To me, again, my personal opinion, it makes all that silicon glass deposit come to the top, and it keeps it right kind of in the middle. That way I know I'm not trapping it anywhere, okay? Let us pray. I'm a little fluid, just a little fluid. It's sagging some. What do you want me to change? Change what? Why? Why change voltage? Okay, my pool is a little fluid and it's sagging, it's crowning up a little bit. I want to turn the wire speed up or I want to turn the voltage down. Which one? I want to turn the voltage down. We'll fight later. I'm just joking. I want to turn the voltage down because I want this to be, I'm going to dry it out a little bit. If I turn the wire up, now I'm going to make more of a sagging effect. I'm filling it up too fast. Okay, so I just want to bump this down a little bit. I'll go down 1/2 volt. And you're thinking, wow, that guy's really nitpicking. 1/2 volt? 1/2 volt makes a big difference to me. Thank you very much. I appreciate it. Because if I got down there, I'd never get back up again. You know what I'm saying? I had the pleasure and the honor of being able to tour an abrasives company. It's 220 years old. Ferd, German company. Man, they make some fantastic products. They're not paying me to say anything, okay? There is a science behind abrasives, and I got one heck of an education. I think we all did. But they've got some cool, unique products, okay? How many of you have been using a wire wheel and you get little wires stuck in your belly or your crotch area or whatever? Yeah, that happens to me all the time too. The wires are spitting. We're now encapsulating the wires, okay? They don't come apart. So I'm just gonna buff this off a little bit. Or am I? I'm gonna buff a little bit off because it's still hot enough that I'm rearranging the ripple pattern. I don't want to do that for you. What's my time, sir? Camera guys. Dang camera guys. Got what? Sweet. Okay. To me, it's a little peaked, but it works. Okay, I didn't violate any of my stuff, and I'm looking down through here. If I had my flashlight, I'd shine it along here. If I see any shadows on the toes of the weld, I know I've got undercut, and you can fire me. Undercut's kind of hard to fix, by the way, isn't it? Got to go in with a file. My bandsaw blades, you know, I can make a bandsaw blade last for about 10 months, but eventually I'm going to start shucking teeth off of it. When I take one off of a machine, I cut it into pieces about 10, 12 inches because those are great for going along the edge of your weld. You can take, if you orient the teeth, you can rake that along there and take off slag, little mill scale, some dingleberries, and then go back with a wire brush. And now your weld is nice and cleaned up on the edges. It's straight. You just don't want to cut into them very bad, but you know, tools. So we didn't leave any undercut behind. The profile, you know, I started out and it kind of felt like this was sagging quite a bit. And I turned it down 1/2 volt and I noticed a big difference under the hood. I really did. And I want to encourage you to kind of play with those settings and whatnot. 1/2 volt to me makes a big difference. I know 1 volt can make or break a weld. And I know that. I've done it a bunch of times where you just, no, I'm not going to go adjust. I'm not going to go do the machine. I'll just suffer through it, you know, and leave it where it's at. And you get done, you're going, wow, I wish I would have go turn that down 1 volt. Because that would have looked a lot better. Okay. So we've got a fair profile. You know, we did the root, we did the fill pass. I've left them here so you can kind of see them. You know, again, it's one of those processes that it's called for quite a bit. I know I've put a lot of students up when they graduate, they go to union halls. They're telling me they're using these combinations of processes. We do TIG roots, we do low hydrogen fills, okay? We do TIG roots, we do gas metal arc welding. We do gas metal arc welding roots. We do hardwire roots and we roll out flux core and stuff. It's all about speed, efficiency, you know, hitting that code, making that weld do what it's supposed to do. As far as the machines, I've had, you know, like when the Rebel first came out, the Rebel 215, Todd and I put one together one day and we were experimenting on running 110 volts, 030 wire, 3/8 plate, downhill root, uphill fill, cap, bend test and x-ray on 110 volt plugged into a wall. And that little machine was running super smooth. It was very impressive. 235, same way. 285, same way. You know, this guy will get after it right here. I threw some 045 and some 95.5 gas on there and pulled the trigger, and we're cooking. So output on these machines, not an issue. Duty cycle, anybody want to argue about duty cycle? I'm feeling frisky. Let's argue about duty cycle. Come on. Nobody? Does everybody understand duty cycle? So we're putting out small machines. You know, these are hobby, but you can do some contracting work with them. And everybody flips out about duty cycle like, well, it's only got like 60% duty cycle or 30% duty cycle. Hey, guess what? You'll never get there. You got to work a machine really hard to kind of get it to that threshold of thermal protection or thermal overload protection. I've done it, but it took a while. You know, I took a little bitty, the Lincoln SP100, plugged that little rascal in one day, and I ran multiple passes in a 1/2-inch plate. Multiple passes, long passes, before the machine ever shut itself down. You know, I felt uncomfortable. So don't worry about duty cycle. You're not gonna get there. Okay? Tough little machine, good output, art features. You know, we want things to run smooth so we can control them. We want to be in control. So the first thing, you know, we can review here. You know, what are we trying to do before we ever pull the trigger? What do we want our root pass to do? What do we want our fill pass to do? That's my whole impression today, and it's very easily attainable. Very easily attainable. You understand how to make some adjustments. You know, the last part of it is you're in control. Your electrical stick out, your wire angle, your travel speed, your technique. It has nothing to do with the machine. It's all you know. And I can't weld for you. I can be there and laugh with you, or you can laugh at me, one or the other. I try to have humor every day in the classroom. We just don't do anything unsafe. But yeah, it's all you. You're in control. And again, everybody's unique. Everybody welds different. We'll talk later. Everybody welds different. So, you know, how many of you are just purely right-handed or purely left-handed? Okay, right-handed? You're left-handed? Have you ever done anything your left hand and you have to brush your teeth with the right hand? Have you ever done that? Stab yourself in the eye with a toothbrush? It's weird. What? It's not fun. What's going on with this is you have muscle memory. Okay? Muscle memory. It's your subconscious. Your body doesn't know right from wrong. You do something repetitively, like the camera guy has a horrible slice, man. He's always hitting the golf ball out here to the right. It feels comfortable to him, okay? So right or wrong, your body doesn't know. You could switch utensils, fork and knife, and that feels strange, doesn't it? It's something, you know, when you do something over and over again, it's ingrained into your body and you think, okay, that's comfortable for me. Welding is no different. It's the same thing with welding. Now, I'm not saying anybody's welding wrong, but if you practice good habits, just like that transition of always coming up the pipe and staying in the middle of the pipe and pointing the wire. I don't know if you could see me on camera, but when I got to the top, it's like my elbow is above my ear. I want the wire actually pointing backwards. It's like I'm dragging it uphill. And goes, what are you doing? I'm keeping the wire on the leading edge of the pool. You didn't see any big buckshot spattering out of there, did you? I didn't. So that's the reason. So, you know, look at how robots weld. Look at how robots weld. They're always changing their wire angle and width to fit the groove. Why not do it yourself? Questions for me? I encourage you. That's all I'm trying to do is encourage you, really, seriously. If I can do it, you can do it. You can do it better, you know? There's some of these welds I don't practice anymore. When I was a young man, like you, I could start on the bottom of an 8 or 10 inch pipe and never stop till I got to the top. I get about halfway up these days, I got to take a nap. You know, I need a cup of coffee and I just don't, my body doesn't work that way anymore. My knees are kind of gone a little bit, but I'm getting old and I admit it. It's all good, it happens. But I'll still throw down with you. I'm not going to lay down yet. Let's have a little fun. Anybody got a $50 or $100 bill? Anybody? 20? Anybody got a $20 bill? We'll have a little fun. Have a little. What you got? Oh, there's a $100 bill. Thanks a lot, sucker. I'll get back to you in a minute. Anybody have any questions? Anybody? If I can help, I don't know everything. Don't claim to know it all. I really don't. I'm in this to encourage. I'm trying to pass along information and knowledge. I enjoy young people that are in the craft and the trade. I try to enroll a lot of people in related fields. The college that I teach at, I've been there 20-something years. We have a full NDT program, which is extremely beneficial for me. I mean, my students, Doug could come in and we could set up a process. Doug Smith with ESAB, give him a big round of hand, or a big hand for putting this on. Thank you. But we can go, you know, we were setting up a processor or something. We go shoot an X-ray of it. We can look at it with ultrasonics. You know, so we have the NDT part there at the college. I'm the DT part. I like to destroy stuff. I'll cut coupons out of here, sand them and bend them and everything else. By the way, I need to throw this out there. If you're going to cut a coupon, you're going to cut coupons and bin test them, please make your grind marks go in the correct direction, in line with the coupon, perpendicular to the weld. I look at a lot of pictures on Instagram. There's a lot of them I don't comment on, but man, I saw some coupons the other day and I almost vomited a few drops. It was gross. Read what you're supposed to do. Free of slag, craftsmanship, finish them with a file, do stuff, you know, but make your coupons look good. You know, some of these guys will go on there and they say, I passed my 5G, and there's a bunch of tears and stuff down the coupon and stuff. Nate and I'd get together and say, I don't think that passed, I wouldn't pass it. You know, understand the codes, understand your allowable limits, okay? Understand what's going on with your machine. Gases, voltages, wire feed speeds, experiment a little bit. If you're in my class, you'll take a pipe like this. We'll finish the weld. We'll grade the weld. I'll put this in a positioner. I'll chuck this up in a positioner, the rotisserie. I've got a plasma torch pointing right at the toe of the weld, and I'll cut this weld out and reclaim the material, okay? That's what we do, and we do it a lot. So, you know, again, it's that muscle memory. Go in and make complete welds. If something doesn't work, take note of it and change it, you know. And if you have questions and need help with something, if I can help you, I certainly will. I think some of you have contacted me, private messages and email and stuff. I don't mind that. If I have time, I'll certainly try to help you out. Again, I don't know it all. I don't claim to know it all, but I definitely want to encourage you because this is attainable. Procedure welds, stick, MIG, TIG. I still like the oxyacetylene and braze and stuff like that. It's kind of fun. I need to introduce these two gentlemen over here. If you think it's me on weld.com, you are mistaken. The gentleman sitting down holding the camera guy, AKA camera guy, Mr. Todd Clouser, is the working horse behind weld.com. There's days I can't get a hold of him. I got a question or something. We're trying to plan ahead. I can't get a hold of him. He's just busy. He's busy. If I have free time, you know, and I try to get back to these messages. Funny story is, there was a time where my phone was blowing up at like 2:30, 3 o'clock in the morning, you know, and I look over and somebody's texting me with a technical question, and my first question back to them is, where are you? The response is like Northern Ireland or Europe, and my response back is, I'm in bed. You know, I'm not even breathing right yet. Give me some time. They're over there sipping tea, you know. They're 6-7 hours ahead of us, so little time deal. But there's days I've tried to get a hold of him and he's just way too busy. The other gentleman over here is Mr. Mike Beecher, AKA the man cub. We like to, Mike and I pick on each other. That's what keeps it kind of fun. He likes to pick on the old man and he gets away with it most of the time. I let it go for a while, but I'm like the old dog. You rub me the wrong way and I'll come out of my cage, huh? All right. I hope this was educational. I hope it was inspirational. I hope it was entertaining. I see you taking notes. You ready for your test? All right. What gas were we using today? On which process? All right, time out. Yo, what do you say?
I said there's a YouTube channel that you can go get more.
Using pure argon on the TIG route, is that what you said? Okay, correct. What gas were you using on gas metal arc welding?
95.5.
Incorrect. The gentleman's response was 95.5. I reserved 95.5, 5% oxygen for the spray process. Okay, 75.25. The two gases that I like to use are pure CO2, 75.25. Okay, use those both. You can short arc and you can globular transfer. If you want to get into that spray mode, you need to be like 90% argon and above. And there's several gases: 90-10, 92.8, 8% CO2, 95.5, 5% oxygen. Now you're wondering, well, why don't you just use pure argon to spray with? Go ahead. I won't, because I've been there. The weld pool is fluid, it's erratic, and it promotes undercut. 5% oxygen makes everything settle down. It's like the weld pool will wet into the parent metal. Okay, so and then, the 8% CO2 does the same thing. By the way, 95.5 in the spray mode, 92.8, you're not running the same values. You got a little chemistry going on there. Okay, so you kind of recognize stuff like that. What filler wire were we using today? I don't like S2. I seriously do not. I haven't welded with it much in my career. I've always been an S6 guy. I can fly with S6. S2 to me is just, I don't know, it's weird. I don't manipulate it correctly, apparently. It's one of my deals, so. And then we were using 035 ER70 S6 on the gas metal arc welding to finish the cap. Okay? 35% inductance, 17.5, 185 on the wire feed speed. And I was comfortable with that, and that's the profile we got. To me, it's acceptable. You can come up and ding me all you want, and that's cool. Can I do better? Yeah, I can. If I practiced up a lot, I could probably throw something down there that make you cry and pass x-ray. Okay? Again, I really appreciate your interest. Thanks for watching and supporting our channel. Thanks for ESAB for putting this on. It's all about the education and encouragement. You can do it. You can do it. Okay? We good? All right. Thank you so much.